section 3.5 is going to be talking about box plots. These are useful as a graphical tool for visualizing a distribution. I actually use these probably just as much as I use histograms because a lot of my data is skewed. And even if it's not, box plots are a very easy way to just get a lot of quick information about data that sometimes you don't get with a histogram. Alright, so when we're creating a box plot, what we need are the following pieces of information. So the first thing we need is we need the Q1, Q2, and Q3. So remember, this is where you break the data up into chunks of 25 or break it up into fourths. So the first fourth is Q1, the second is Q2, aka the middle 50%, and the third fourth, the 75th percentile, is going to be Q3. We also need to calculate the IQR, and the last thing is we need to calculate 1.5 times the IQR. So I did that in a different color because these two pieces of information are going to go on the box plot. This last one does not go on the box plot. Okay? What it's going to do, though, is it is going to help us to find potential outliers. Okay, so when we create that 1.5 times the IQR, what we're going to do with that number is we're going to subtract it from Q1 and we're going to add it to Q3. So what that's going to do is that any number outside of this interval, so outside of whatever Q1 minus 1.5 times QR, and anything outside of Q3 plus 1.5 times the IQR, is going to be an outlier. So we're going to call this our lower fence. So anything below this is going to be a potential outlier. This we're going to call our upper fence. So anything above that is going to be a potential outlier. So let's look at an example. Let's say we're collecting data on the price of milk around town and we get the data below. So let's say that while we're looking at the price of milk around town, let's say instead of going to store to store, we ask people. And let's say that we accidentally ask somebody who's from, say, Hawaii, and they're like, oh my gosh, milk is so expensive, it's $6.50. So what we have here is that we have 15 observations. We want to find Q1, the median, aka Q2, Q3, the IQR, and then we want to find 1.5 times the IQR. Remember, that's not going to go on our box plot, it's going to help us find potential outliers. So, if we break this data up into fourths, our middle observation, since we have 15, so let's see, 15 divided by 2 would give us 7.5, so the 8th observation is going to be the middle. 1, 2, 3, 4, 5, 6, 7, and 8. Alright, now I'm going to break this side into in half and find the first fourth, so that'll be 1, 2, 3, 4, and 1, 2, 3, 4. So my first quartile is going to be 2.97. My Q2, or my median, is going to be 2.99. Q3 will be 3.08. My IQR, that means the middle spread of my 50% of data, is going to be 3.08 minus 2.97, which is going to be 11 cents. That means that most milk is going to cost $2.99, and most milk is only going to vary by 11 cents. Now, 1.5 times the IQR, so we're going to have 1.5 times IQR, which in our case is 0.11. And I'm just going to round it up to the nearest cent. I'm going to say that that's 18 cents. Now, we're going to use this information to draw the box plot, but first we need to find potential outliers. So, potential outliers . First, we need to find our lower fence. So our lower fence is always Q1 minus 1.5 times the IQR, which in our case is going to be 2.97 minus 18 cents, which is going to give us 2.79. Our upper fence, whoops, is going to be Q3 minus 1.5 times the IQR. So Q3 in our case was 3.08 plus, oh I'm sorry, that should be plus 1.5 IQR, plus that 18 cents, which is going to give us 3.26. What this means is that values outside this range, whoops, are going to be outliers. So let's look at our data and see if we can determine if we have an outlier. So first off, do we have any values that are lower than 2.79? We don't. Our lowest value is 2.93. And if we go through our data, do we have any numbers that are bigger than 3.26? Well, we do. We kind of create an artificial one. It's this one. So what that means is that we're going to treat 6.5 as our potential outlier. Now what we're going to do is we're actually going to draw the box plot. So here's how you're going to draw the box plot, is that first we are going to draw where the first 25% of our data is. So the first 25% is going to be from about 2.93 up to 2.97. Now when we start to draw the middle 50%, what that's going to be is those are going to be boxes. So we are going to draw a box to 2.99 all the way up to 3.08. And then we are going to go up to 3.19. So what that means is that this middle part is going to represent our IQR, which is going to be the middle 25% of the data, and then each piece is going to represent 25%. Now, notice that we did not put these values on our box plot. We still need to put down, however, that somebody told us that they were going to spend $6.50 on a gallon of milk, but we also want people to know it's an outlier. So what we do is that we put a star of some kind in our observation. So the star is saying, hey, this isn't connected to the box plot because this is a potential outlier. Alright, so I would like you guys to pause the video, use that example, and try out the next couple examples on your own, and then come back and check your work. After that, what we will do is we will go over the beware of box plots. Okay, so go ahead and pause the video and go through these on your own, and then come back and check your work. Alright, so if you are back and you have checked your work, on the next example, when we find our Q1, Q2, and Q3, what you should have gotten is you should have gotten 50, 54, and 64. Okay, so Q1 should be 50, which means that 25% of our data is 50 or less. Q2 would be 54, so 50% of our data is 54 or less. And Q3 is 64. Our IQR is going to be 64 minus 50, which would be 14. And 1.5 times that IQR is going to be 21. Now we still need to calculate our lower fence and our upper fence so we can find potential outliers. So that's going to be 50, which is our Q1, minus 1.5 times our IQR, which is 21, which is 29. Oh my gosh, upper fence is going to be Q3 plus 1.5 times our IQR, which is going to give us 85. That means that values outside that range of being between 29 to 85 are going to be potential outliers. So if we look back at our data, do we have any values below 29? We do. We have 2. And do we have any values above 85? Yes, we have 89 and we have 130. So when I draw this on this chart below, and I'm creating my box and whisker plot, I'm going to start with my lowest non-outlier observation, which I believe was 43. So we're going to start at 43. Then we're going to go to Q1. So let's see, Q1 was 50. Then we're going to go to our median, which was 54. Then Q3, which was 64, so about right here. And then the next one we're going to do is going to be our highest non-outlier, which was 70. So remember, only observations should go on your box plot. So this is Q1, Q2, Q3, and remember, these dots are the highest non-outlier, and this is the lowest non-outlier. We still want to tell people that those outliers exist, so remember how we do that is that we're going to put stars where those occur. So we're going to have a star at 2, which was a low outlier, at 89, and at 130. This is great because we're still telling people, hey, we saw really weird, peculiar observations here and here, but most of our data was actually very compact. Okay, great. So on the next one, we asked people the items of, or the number of items that they typically left the house with. I don't know anybody that leaves the house with less than 3 objects, but whatever. Keys, phone and wallet, that's just me. So we have 35 observations. So the middle observation would be, let's see, 35 divided in half. That would give us 17 and a half, so it's going to be the 18th observation, which I believe is 4. Yep. Okay, and then we are going to count in, so let's see, that's going to be the 18th observation, so then divided by 2, so this, let's see, 1, 2, 3, 4, 5, 6, 7, 8 observation. Okay, and then that one, so our maximum value is 20, our minimum value is 1, Q1 was 3 objects, Q2 was 4 objects, Q3 was 6 objects. Our IQR would be 6 minus 3, which would give us 3. So what this means is most people carry 4 objects and vary by at most 3 objects. All right, so we still need to find our lower fence and our upper fence. So our lower fence is going to be 3 minus 4.5. Remember, that 4.5 is 1.5 times the IQR. So we're going to get negative 1.5. And the upper fence is 6 plus 4.5, which is going to give us 10.5. Now, it might feel weird to have a negative number, but all that means is that we're not going to have a lower outlier. So you can't leave the house with a negative amount of items. So that means that we don't have any lower outliers. 10.5 means we are going to have some high outliers. So we can keep these 10s, but we can't keep the 15 and we can't keep the 20. Those are going to have to be potential outliers. So when we create the box and whisker plot, let's see, we're going to make this 0 and make this 20. We'll have 10 in the center, 5, and 15. So we're going to have our lowest non-outlier, which was 1. We are going to have Q1, which was 3, so that would probably be about right here. Then we're going to go up to Q2, which was 4, Q3, which was 6. Remember, Q1, Q2, and Q3 are going to make up the box part. And then remember, our last whisker is going to go up to the highest non-outlier. So that's going to go up to 10. So we're going to have 4 and 6. And those are Q1, Q2, and Q3. And finally, we need to put stars on where those potential outliers were, which were at 15 and 20. Great. Now, something to keep in mind is they're called potential outliers, because even though this comes up as a potential outlier on a box plot, when we look at the actual histogram, that data is not far away enough for it to be an outlier. So that's why we call those potential outliers. Okay. Also note that we get less information from a box plot. So for example, if our data is multimodal, we lose that information on a box plot. A couple of other things that you lose on a box plot is you don't get the mean, you don't get the count or the frequency, so you don't know how many observations you actually have, you just know where the 25%, 50%, and 75 and 100% are, and you get a lot less detail. So they're really great for quick snapshots, but they don't give you a lot of detail. All right. They do make it a little bit easier to compare two things quickly. So if we look at Montreal, Canada versus Anchorage, Alaska, and the amount of daylight hours, what we can see is that they both have the same median, but we can see that Alaska has more variation. All right, the last thing we're going to talk about is how can you tell if a box plot is skewed? So you have to assume first off that the data is unimodal. After that, if we have our data and our box plot is short, short, and then long, here's what that means. It means that we have to squeeze 50% of our data into a small space, and then we have to drag out the other 50% of our data into a long space. So what that tells you is that you have to squish 50% of your data and then drag the rest of it out, which means you're going to have right skew data. If you flip it and the first half of your data is elongated and then the second half is squeezed together, then you're going to have left skew data. If it looks any other way, so if you have long, short, long, and short, what that means is that it's inconclusive. All right, so that is it for chapter 3. The next video is going to be doing a couple of examples on basically everything from the chapter. So it's going to be looking at standard deviation, how to find standard deviation, how to use StatCrunch, how to find a box and whisker plot, and how to use the empirical rule. So get ready for that.